So in this video, I want to talk to you about solution sets. Now, what I mean by that is that when we solve an inequality, we may find that our answers for x are greater than 2, but less than or equal to 7, for example. Now, in that format, I would take that to mean that x can be any number that is larger than 2, but smaller than or less than and equal to 7. So that would include the numbers 2.01 or 2.001 or 2.0000001 or 3.56891. Okay, so it can take on any real number in that range. So there's essentially an infinite number of values that it could take between those two. Okay, now that in that format is perfect for that. What I could say, however, is that x also has to be an integer. So where x is an integer. Now, if that's the case, then x can only take on specific values in that range. And that means we would work with a solution set. So I'm going to use a curly bracket and say that x would then be an integer that's greater than 2, but less than or equal to 7. So that would include 3, 4, 5, 6, and 7. And I separate them by commas, and I have these curly brackets either end, and this is my solution set. So we would refer to that as a discrete solution set, whereas this by itself, okay, if I didn't have where x is an integer, then we would refer to that as a continuous solution set. Okay, that plus that little bit of extra information leads to that solution set. Okay, to be clear. So you can have a continuous solution set where you're allowing any real value between two endpoints, essentially, or you can have a discrete solution set where the solutions can only take on these specific values.